Welcome to this short video on how electricity markets work and how the price is set in an electricity market. We're going to be looking at the South African power system, where these are the 5 major generators. There are other generators, but these are the largest 5. Coal, diesel and gas, wind, solar PV and nuclear. And those are the installed capacities of each generation. In 2023, South Africa had a peak demand of 34 gigawatts. So we're going to look at how these generators are dispatched to meet that peak demand. For a typical winter day, this is the load profile. So you can see the time of day on the x-axis and the demand in gigawatts on the y-axis. So as people start waking up, electricity demand increases, and then it reaches a sort of low or dip in the middle of the day as solar PV, rooftop solar generates, and people use slightly less electricity. And then people go home after work and start cooking and showering and using much more electricity. So it reaches its peak demand in the evenings. And then as people go to bed, electricity demand reduces. So the question is, what is the price at each of these hours of the day? So we're going to start with the 2 a.m. hour, the lowest hour of the day, and see how the generators are dispatched to meet this demand. On the left-hand side, you can see the available generators at 2 a.m. The sun's not shining, so solar PV is not available. It's obviously a windy morning, so there is a bit of wind. Coal, of the 39 gigawatts installed, only 25 gigawatts is available. Diesel and gas has 3 gigawatts, and nuclear has 2. So each of these generators say what their price is, their marginal price of supplying electricity at 2 a.m. Wind, and you can see on the graph on the right-hand side, you plot the quantity available and the price on the y-axis. Wind has the lowest price. It bids in at a 0 marginal price because it doesn't cost the wind generators anything to generate more electricity. They've already built the wind turbines, so the marginal price is 0. Nuclear is, our nuclear facility is almost fully depreciated, so their marginal price is also very low, 10 cents per kilowatt hour. Coal bids in at 49 cents per kilowatt hour, and gas at 707. So for gas, their price is largely driven by the cost of the fuel. The demand at 2 a.m. was 23 gigawatts, which crosses through sort of midway, just beyond midway of the coal generator. So in order to meet our 23 gigawatts at 2 a.m., we're going to use 3 gigawatts of wind, 2 gigawatts of nuclear, and 19 gigawatts of coal. And this process of using the cheapest generator first wind, then nuclear, then coal, then diesel, this is called merit ordered dispatch. And this is a key concept in electricity markets. So if we come back to our graph on the right-hand side, we used the cheapest generator first, and we saw that coal was the most expensive generator that was being used. And so we say coal sets the price. And this concept of the most expensive generator that is being dispatched, setting the price or setting the marginal price, this is a key principle in electricity markets. And what it means is, if we want one more additional unit of electricity, so if the demand increases slightly, this is what it would cost. And so the price at 2 a.m. is the coal price, which if we draw it across onto the y-axis, is 49 cents per kilowatt hour. So the price of electricity at 2 a.m. is 49 cents per kilowatt hour. Now, if we look at the second example, which is in the evening at 7 p.m., let's see what the merit ordered dispatch looks like at 7 p.m. So again, all the generators have said to the market operator, this is my available capacity at 7 p.m. and this is my price. So now we can see that wind has fallen away. It's obviously a still evening, no wind. And solar is saying they've got 1 gigawatt available. In reality, maybe this is not realistic. 7 p.m., possibly the solar has already, the sun has set, but just for the sake of an example, let's go with it. So at 7 p.m., we plot the generators that are available, and then we cross that line where what the demand is. So in this case, the demand is 32 gigawatts. It crosses the gas line. So the price of electricity at 7 p.m. is 707 cents per kilowatt hour, or 7 Rand per kilowatt hour. and gas is setting the price at this time of day. So if we look at the 2 points that we've plotted, at 2 a.m. the price was 49 cents per kilowatt hour where coal was setting the price, and at 7 p.m. the price was 7 Rand per kilowatt hour where gas was setting the price. Now this high price in the evening can attract investment in cheaper generation capacity. And I've tried to add an example here illustrating the point where wind in the blue comes online. The wind generators build and invest in order to try and reduce the price or access these high prices. And so what happens if we make an illustrative example here for 7 p.m. At this point, wind has come in and pushed gas out the system, thereby reducing the 7 p.m. price to coal's price again. So now coal sets the price, but this is just an example to show how cheaper generators can push more expensive generators out, thereby reducing the marginal price of generation. So the two key market concepts covered in this video: first of all, merit order dispatch, using the cheapest generator first, and secondly, marginal pricing, this one that the most expensive generator sets the price. Thank you for tuning in. Hope that was useful.